Hey everyone, welcome to Data Productions, another podcast. So today we have Swapnesh from Cars 24. He's a senior machine learning engineer at Cars 24. So you're going to be talking about, what does an ML engineer really do, the kind of work an ML engineer does, and how ML engineer works hand in hand with other domains and other people's, the data scientists, data engineers, and so on. And we'll learn a little bit about the different architectures that Cars 24 are building. So thanks, Shopness, for taking time out and you know to be here, and it's a pleasure meeting you.
Yeah, same here. It's a pleasure doing this. Actually, it's the first time I'm doing this, so I don't actually know how things go in this.
All
So,
good, all good. Not have to be nervous. It's gonna be
yeah,
amazing. Yeah, do you wanna start with introducing yourself about what you did as a background and just how you got here.
yeah, sure. So I did my BTech in 2016, and I started my journey as a data scientist. Uh, so I was around data scientist. I was around for I think some 4 odd years, and like the last four, I think I would say five. Yeah. So the last fourth and fifth year, I was more involved in the deployment and you can say taking care of infrastructure part also, along with the training the model and all that data processing. So there was a time where I started developing interest in that field also, because what I felt was the training of the model was becoming easier day by day due to more tools coming in the market. But what remained a gap was how to deploy these models effectively. What challenges I faced in those like fourth and fifth year were that there were not many resources on how to effectively deploy the model, and rather there were not many people to get in touch in the whatever org I was working in, or people around me. So like I started learning all those things on my own, and deployed a few models in the previous company which I was working on. Uh, then while working in my previous org, like I was like contacted through LinkedIn itself that we are building this team in Cast 24, and we want to have a, like, we are building the MLOps team as such. And at that time, I wasn't even sure I wanted to shift to this domain, but I had some sort of interest in this field. So I had multiple talks with my current manager and other folks in the team, and it felt like this is some interesting problem to be solved. So that's how I shifted my career from data science to like at that time we started calling it MLOps, but we more like feel that it's more of a ML eng, because we are not doing only ops part. We are actually solving engineering problems, uh, not related to just deployment of the model, more of how to effectively create that whole pipeline to deploy these models. And it even involves tuning the model and tweaking different parameters of the models if necessary.
Mhm.
So we call it as an ML eng right now. So we call ourselves ML engineers.
Mhm.
So that's
Yeah,
how I shifted.
yeah, right. Yeah. I think the name matures. I think back then people were not aware of, what it is and so on. Like, data
Yeah,
science. People have been doing that for so many decades, but it wasn't, up until last decade that the name came up, right?
yeah,
Similar thing with MLOps, right?
yeah,
People didn't know what it is, and
mm,
eventually, okay, machine learning engineer. That's why the name popped up.
yeah.
How do you so how did someone reach out to you on LinkedIn where you were active on LinkedIn? Because that is something that people don't understand. It's a platform
Okay.
where you can take advantage of it. It's just that people are not aware how to take complete advantage of LinkedIn.
So
Mhm.
yeah, so it's actually I would say a funny story as such. If there's a like blog which I've written, in that there's an anime image where it's from Food Wars. It's an anime. So that person is cooking on multiple pans. So that image, it was posted on LinkedIn by some person, uh, and it was related that this is how you deploy models, or this is how you do deployment. You create multiple instances of everything. So my current flatmate tagged me on that post that this is exactly what you do. And uh,
I see.
my current manager was working with him in his that time current company. So he
Mhm.
saw that he has tagged me in this post, and he had left that company and joined Cast 24.
Mhm.
So he saw
Okay.
that post, and that's how he contacted my flatmate that is he looking for some change, or is he looking for getting into this field. So he gave him my contact, and then we started talking, and that's how I
So
got
it was
contacted
small,
on.
like Cars 24 when you were contacted versus
No, no,
how
no. Yeah.
today. Or,
So so I was in before Cast 24, I was in Quantify. So
Mhm.
at that time, like that, I had just joined Quantify in 3 4 months. So
Mhm.
at that time, he found out about me.
Mhm. Really interesting. Right? That doesn't happen these days. These days, look
So
up
yeah,
LinkedIn.
it was
It's
just a coincidence, I would say.
uh,
That
I think
yeah.
it still happens. It happened with me last year. Like I was just shit posting on LinkedIn, and
mm,
someone contacted me and gave me my current job.
But you were active, right? Like you're active on
Yeah,
LinkedIn versus Swapnesh, like he wasn't active. It just as
yeah,
someone tagged him,
yeah,
right? So if you're active, yeah, I can understand people reaching out. But
mm,
someone who's not active, people don't know him. It's really interesting that just by a tagging,
yeah.
he got an offer. Interesting story. So tell us about your so you started out as a software development intern, right? So you also you saw the world of software engineers, and now you're in the world of ML engineers. So tell us the difference. What do you see the main differences between the two roles?
so tell us the
Uh,
differences between
mm,
software, data
Mhm.
scientist, MLOps engineer, and machine learning engineer. All
Yeah,
of these.
let's start that way.
yeah. So software engineer, my internship was a full stack engineer part. So I did front end and back end both. So front end, I would say, is not much related, but yeah, back end is definitely related to whatever ML engineer is doing, because at the end of the day, you have to write a good code when you're deploying a model. Just doing model training and throwing resources at your API won't solve it. So that is something software engineering teaches you, that you have to write code which is production ready at least.
Mhm.
So there are multiple things, like you don't need pandas and numpy, all those sort of things generally in your production deployments. So those sort of things come up. What I feel is that when you write code and measure its performance also, not just writing code for a training pipeline. So I would say software engineering helps in that. Uh, what comes after that is you get introduction to platform, and by platform I mean cloud resources and all those things. So generally software engineers don't get involved in those, because these things are generally offloaded to DevOps part of the teams. So that comes up when you are still a full stack developer, or you have started getting into tech lead sort of roles or architecture level sort of roles. That generally doesn't happen when he like at the starting of your career, because these architecture level roles generally come up when after you have done 8 years, 7 years of experience in normal back-end coding or software engineering as such. So I would say if someone is starting as an MLOps engineer, then it's a lot of small different pieces that they have to get in touch with to effectively learn how everything works. So they would have to learn about little bit of software engineering, how OOPS concepts are there, what OOPS concepts are there. They would have to learn about how cloud resources work in general, and that involves also some sort of system knowledge, like what are threads, what are cores, how are threads involved in when the model is running. That sort of understanding is needed when you are doing an MLOps pipeline, because at the end of the day you have to save cost uh, when you're doing that pipeline thing. So there are very like bits of pieces of everything involved when a person wants to be in MLOps and MLng as such. Front-end engineering is not that in like needed as such, but yeah, that also helps if you're like the team is small. So you'll have to end of the day you'll build a small Streamlit app. That would also help. Whatever you are like, you want to show your model, then what is it you want to show? But yeah, backend engineering is something which is needed.
Is that, do you think like that's the biggest barrier, these days, to break into ML engineering role? Because, a lot of people, yeah, they want to get into data science, but also a lot of people don't understand the difference between what a data scientist does versus what an ML engineer does. Plus on top of that, then there's no proper training, right? I think you come from, because you worked as a software development intern, you come from that background, you picked up a lot of the software engineering principles that really gets applied.
Yeah.
And I think that is something that even scientists apply in their day-to-day work, like best practices, how you design uh, projects and all that stuff, right? So do you think that that is something that's currently lacking when it comes to juniors and, fresh graduates?
Yeah, definitely. That's something which generally lacks in any company. So this is something a fresher would be able to get hands on only when the team is very small. If the fresher starts working at some company where there is a bifurcation of everything, then they won't be able to get in touch with uh, the coding part as such, like how to do effective coding. Because I've seen in many companies that data scientists, they train their models and just give it to whatever backend engineer or software engineer there is, and they develop the whole API around it. So at the end of the day, they won't get any info as to how they are doing the deployment and anything, and they won't be involved at any point around whatever resources are required for the model, or how is it performing in the real world, that API. The model performance is different, but API performance, they don't have any clue. So a starting career with some small teams generally helps, because you get to work on more things. But yeah,
Since you were a data scientist before, can you tell me about what are the overlaps between data scientist and ML engineer, and what are the differences?
okay. So overlaps as such would be in terms of just a simple deployment of models. Uh, so data scientists won't be like general data scientists won't be concerned about scaling initially. They won't be worried about number of requests, concurrent requests, and those sort of things. So they won't look at things like Kubernetes or Docker Compose as such, which can scale their containers if they are working on containers. generally what people start doing is that they write a Flask app or Fast API app. They deploy it on a VM, not even on Docker itself, just Python code running. So that's just a starting point. That's how you learn. Like that's how even I learned that my first deployment which I did was on a VM EC2 instance on AWS. But when that API was running and tech was doing the testing, they said that your API is not giving response at some point. Why? Because they were sending around 100 requests per second, and I had no clue how to handle that part. So I had to Google and search about it. So how to, like, how people do this, because Python is not thread ready. So obviously there is nothing as such threading going on in that part. So there must be something else. So that's how I got to introduced to Docker. Then Docker Compose, then comes Kubernetes, all those things. So once the data scientists, they start writing APIs, and they are the ones that who have to take care of the scaling and everything, then they can get into something like how to optimize all those parts. In general, people don't get into Kubernetes and as such data scientists, because everything depends on the number of like the amount of scale the API wants. So maybe something like if they have deployed on something like on cloud functions, so that also works because cloud functions, they scale on their own. So they can, the basic thing that they can do is do on cloud functions or cloud run on GCP. The next step comes when they see that the cost is shooting up, because cloud functions and cloud run, they are costly for the amount of time they are running and whatever resources they are consuming. Then comes the next part of how do I skip this and get into something which is cheaper. So then you start researching about good Docker Compose, which you can run on VM. So this is me telling about how I got till Kubernetes. So Docker Compose runs on that VM. It will scale the pods on that VM. At some point, that VM's resources will get full. Now what do you do? So you need something which scales the pods also, and you need something which scales the VMs also. So then you research about Kubernetes. So the overlap basically comes when you start deploying things. If you are not involved in deployment of your model, then there won't be an overlap at any point, because your job finishes after the training, and the other part of your job is model monitoring and not API monitoring. So that is the overlap. What data scientists generally, like, they don't want to get involved is this part only, the deployment part, because they feel that this is not their responsibility, that how is that API performing, that is the part of someone else. So at some point, like I feel both the things are at I won't say that this is wrong and this is right, because if one person starts doing everything, then what's the job of the team members? But yeah, this is true for when you are having 2-3 years of experience. It makes sense that you don't want to get involved in everything because you are learning one thing. But if you want to progress further, you cannot stay away from the whole environment which you want to work in. Even like if you want to get into principal data scientist role, you want to understand how things work, because your knowledge cannot be limited to just this training of models. You have to understand, because at some point you will get into deep learning,
Mhm.
and deep learning models perform very differently than uh, like classical ML models. So at that point, you'll have to get into how systems are built, which scale according to deep learning models, because their requirement is very different from tree-based models. So initially, I would say like data scientists, they can uh, hone their skills in data science field, but they have to get in touch with some part of the deployment uh, process also if they want to proceed further.
Mhm. Yeah,
So yeah, that's it basically.
yeah. I think it's number of factors. Like I think data scientists, why I can understand why they wouldn't want to do that. I mean, it's a big responsibility and a whole new set of skill sets that they have to learn. I mean, ML engineers like you guys have spent years of uh, you know years of learning. So you guys have years of experience where you have learned every set of skills and tools that you guys need. With data scientists, I think it's the amount of work as well, right? I mean, depends on company to company, right? So for example, in our company, we do the ML, like the modeling and all that stuff. But at the
Mhm.
same time, we also have to handle the data request
Yeah,
from the different departments. So the workload kind of increases, right? So you're doing forecasting project, which is again, it's not pure like something that you really have to care about when it comes to deployment. I mean,
mm,
to deploy it, but not at that scale. It's just a batch learning process
yeah,
versus you have deep learning projects where it's a hardcore deployment process, and then you have a data request. So
mm,
given I think that the amount of work that a data scientist would have to do depending on the company, I do see it. It just and plus factoring in how much the company cares about you,
yeah,
right? How worth you are to the company. I mean,
yeah. At some point, like the person feels that am I getting paid enough?
exactly. Yeah.
Yeah.
Right. And given the trend of layoffs, right? Like
Mm,
people give their entire career to the companies, and at the end of the day, what happens, right? So I think that all of that, having that in the mind, yeah, that which is actually a good thing because now it gives rise to a totally new field, machine learning engineers. You have new jobs
yeah,
that people can take on. Um, Thanks for describing, the whole process. And like I said, not many people know the distinction between the two fields. There's a lot of overlap, but again, people don't understand where they exactly overlap, and this kind of puts it into perspective.
yeah.
Um, and so, another question I usually get is, how is DevOps different than MLOps, right? And you work as an ML engineer. Do you also have to work with the DevOps people?
Yeah.
And you guys also work with data engineers. Right? So we'll get there, but how?
Mm.
Let's talk about MLOps and DevOps.
So there's a lot of overlap in that part also. Uh, but what I've felt is that DevOps has a lot more responsibility on the networking and security side also.
Uh-huh.
As an MLOps engineer, I would require their support to make my API secure and such that proper networking rules are followed. I wouldn't want to get into that part because that's an entirely different field and it has a lot of other concepts which need like studies, and
Uh-huh.
you have studied networking and
Uh-huh.
OS in BTech also. So networking is not easy. There is a lot of things were running there. So as an ML ops engineer, your responsibility basically, like first responsibility lies that your pipeline, which you have built for training or deployment or monitoring, that is running fine. And you are able to deploy models seamlessly. They are monitoring is done seamlessly. The APIs are scaling perfectly. Those sort of things. This part is something which generally companies already have. They have set up a few rules, like how the APIs will be exposed uh, if they are running behind some VPN, or those sort of things. So generally MLOps engineers, they would need help of DevOps to follow those security like guidelines. SecOps also comes into picture at some point. So that's why this field, like when you uh, have more years of experience, you see that these fields like get diverged at some point, because uh, at one point of time you have to restrict yourself that this is not something I'm going to get into, because if you put your hands in everything, then like there's a saying that master of none. So that happens. Like I'm not saying that you should not have any understanding of it. Definitely you should have understanding of it, but you should not take care of that pipeline which is running on the DevOps side. But you should be well knowledged on that part, that you are able to have conversation with them, that this is something my API is doing, this is how I am running things, how do I integrate with the tech, how is the tech API going to call my API, and what is the procedure, what is your VPN setting or VPC setting. You should know these terms at least, so that you are able to talk to them. So that is, I think, the overlap comes. Networking, communication, and security, those part of things. They obviously know infrastructure also, but infrastructure requirement for a model is very different for infrastructure requirement of backend APIs or front-end APIs. So that is something you have to take care of. So yeah, that's I think the overlap is.
Can you tell us about what do you do as your like daily work, like, or like what did you do in the last 2 weeks at work?
Uh, so the basic, like I spend a few hours, I think 2-3 hours, just to look at how things are running, like what are different pipelines which we have built, how is their status. We have different Grafana dashboards running, so I take a look at those, then I
Dashboards also you have to build or someone
yeah,
else builds?
yeah, so we as a team are a data platform team,
Hmm.
so we build everything surrounding model deployment, or even things required by data entity. So that Grafana dashboards we build, how Grafana and Prometheus are deployed, those also we take care of. Everything on Kubernetes. So first, like I take care of, like I look at those dashboards and see if any alerts are being triggered as such. Other than that, I take look at of the billing page, whatever our GC project is billing. So there I can see if some spike is there for any component which is running on our project. So I can have a look at what is that spike as such. So these are basically the monitoring things which I do every day. Other than that, so once you get into ML Eng and MLOps, so you start understanding how platforms work, because you have to work with a lot of open source tools. So like since the last, I think 4 to 5 months, I have been involved in building the data platform, which is more of a data eng side of thing. So not getting into entirely data eng, but building that platform, you say, or a sort of warehouse. So that warehouse is basically able to handle real-time dashboarding, real-time queries or streaming data, those sort of things. So last 4 or 5 months I've been involved in those part. So yeah, so currently working on that part, but every day at least 1 or 2 hours I just look at things how they are running,
Mhm.
so that I still have a sense of whatever is there on that whole project.
Since you mentioned about the data pipeline, let's actually dig a little bit into it, and also talk about the tech stack, the tools and stuff that you use. So I'm not sure if it's one of this articles. So I'm going to share my screen. Um, let's do this one. Okay, can you guys see my screen?
Yeah.
Yeah.
Okay, so is it one of these like data flow that you were trying to optimize?
Yeah,
So,
so this is something which we did like last year, or I think like 1.5 years back. So these are the small building blocks basically through which we were able to identify that we have confidence in building tech stack or platforms or pipelines. So what we like, so Cars24 has a lot of operations heavy teams.
mhm,
So these teams generally rely on Google Sheets or some dashboards where data is getting populated at some interval, like 10 minutes, half an hour. So these are like Google Sheets and even Snowflake dashboard or Snowflake data sets which get populated. And I would say there are a lot of sheets and tables which are being used by these business people.
mhm,
And what the pipeline as such is to sync this data between Snowflake and Sheet. So, and because there are around 2000, like I think it's close to 3000 tables and 3000 sheets as such, and every sheet has different spreadsheets too.
mhm,
So I would say around 10,000 odd some spreadsheets are there.
mhm,
So every spreadsheet has a query which runs on Snowflake, and then the data comes from Snowflake to Sheet, and the same thing reverse happens from Sheet to Snowflake because people update things on Sheets.
mhm,
So this, so you can say around 10,000 queries have to run in some 8 to 9 hours of the business time, basically 9 to 5 or 9 to 6, whatever you call it. So these are queries which run for you can say at least a minute or so for second. Some run for 10 minutes, like heavy queries. So you don't have enough time,
mhm,
basically. Then you don't have enough hours to run everything and get everything updated. So initially this was running on a VM, and what was happening that obviously the VM's resources were getting full. So at some point we realized that just increasing the VM size is not the ideal way, because that will never stop, and you won't even know when the error is coming. Uh, you will only know when someone pings you on Slack that my sheet is not getting updated or my
mhm,
table is not getting updated. And
mhm,
at that point, you can't go and update the VM and then run everything again. So what we identified was that instead of running these queries, like not queries run on Snowflake, getting this data in a VM, it's better to offload it to something which we can scale, and we don't have to take care of that scaling. Then that is Cloud Functions. So submitting the query to Snowflake, getting back that data, and updating the sheet. This is one pipeline. And I do not want to run for 10,000 sheets on a single machine. So rather distribute it on a cloud function. And what I need is that I am able to schedule this thing. So for that, I have Airflow. So I know that for this hour, like from 9 to 10, some 15 sheets are there which need updating, or 15 tables are there which need updating from sheet. So I can schedule jobs on Airflow such that they can run concurrently, and even like 10-15 cloud functions can spin up. They can run those queries because Snowflake is a warehouse, so it can handle all those 15 queries as such, and everything gets updated in parallel. So through this, we are able to reduce cost also, because cloud function they run. So initially there was a high cost because we were waiting for the result to run return from Snowflake, and cloud function charges you time for whatever time you're running the cloud function for. So then we identified that Snowflake has a functionality of you can submit the job, get a job ID, and that you can query ID, sorry. So you can use that query ID at some later point to fetch the results. Snowflake stores those results. So doing this, we were able to reduce the cloud function runtime to some seconds, because we just had the job of submitting that query and getting back that query ID. And at some later point, I can run another Airflow DAG, which just fetches all those query IDs which were submitted in the last 10 minutes and get the data from Snowflake. And that can run on separate cloud functions. So through this, we were able to reduce our cost like up to 60-70%, because things were running in matter of seconds, because we have to submit the query in second and we get back the results in seconds also. So through this, we were able to solve the problem of resources getting consumed and saving cost also. Plus, this is fault tolerant also, because we can write code in cloud function that retry, whatever you can do. And Airflow also, if some DAG fails, you can add retry to itself. So it can retry the task also, just in case any issue comes on Snowflake side or cloud function or sheets. And through this, we are able to control the traffic which is flowing to the Google Sheet API, because Sheet API also gives you fixed number of requests which you can submit in a minute. I think it's 60 or some not. I'm not able to remember the number. So we can control even that send only these parallel requests to the Google Sheets, then wait in the code itself, in the DAG itself, and then again send those things. So we have a lot more control when we are scheduling things through orchestrator like Airflow. So this is the optimization which we had done.
So in terms of the query versioning, right? I mean, I'm not much familiar with Snowflake, but so do you guys utilize GitHub anywhere in the process? Because I know you have code on Cloud Functions, but let's say for some reason you have to tweak the code a little. So do you guys utilize like GitHub where you make the changes, then that goes on to the Cloud Function, so you have the code versioning at the same time?
Yeah. So in our company, we use Bitbucket, and because everything is on Google Cloud Platform, so we do the mirroring of Bitbucket to Google has cloud source repositories, and we use Cloud Build, so that whenever you push in your Bitbucket repository some change, the Cloud Function automatically gets redeployed through Cloud Build.
Got
So
it.
that sort of versioning is also there, number of changes is also there. The control lies with the data eng team, and whatever the BI folks are there, so they can control whatever queries running on those cloud functions.
The couple of things also you talked about in this article is, the importance of monitoring and logging, right? So you mentioned, static. So you have like the model versioning, which is by using, let's say, tools like MLflows, and then you have the data versioning, which is, you guys are utilizing GVC, for instance. So, tell us about that. And at the end, also, you guys are using Slack and the databases to store some logs and stuff, right? So yeah, tell us about that.
So yeah, so model monitoring. So we are not involved right now in training part.
Mhm.
We have taken care of the deployment part of the problem of the pipeline, because training pipeline is something which is very difficult to tweak for the data scientists, because they are used to train their models in a like fixed way. They are used to some sort of notebooks, some environment, and they would rather uh, do those part instead of uh, getting to learn some different tool like MLflow or Kubeflow. So we decided that the problem to solve is not training. That will be a problem when people want scalable training. The problem is now scalability of the deployed model. So in that part, so what we had to take care was, when we deployed the service, how do you monitor your model's performance and how do you monitor your API's performance? So model's performance is something you don't need daily as such. So you might need it weekly. So there are multiple tools. So one is evidently AI. So you can tell the data scientists about those, because at the end of the day, they decide on what metrics they have to monitor the models. So they will have to learn about evidently. That is not something we can do. We can just provide that pipeline. So they can go on evidently, they can learn about what all metrics there are, and we can build the pipeline so that so there are so in this pipeline, there are multiple microservices also running, which we have developed, like inference store is there, which basically saves whatever inference the model had generated for a particular input. So it serves two purpose. First is that you don't want to recalculate everything. Let's say in case of a deep learning model, same image comes twice, thrice. Don't want to run the entire prediction again. I would rather fetch whatever was predicted before. That is one problem which that solves. The other thing is that I have a place where I have saved everything what the model had predicted, which the data scientist can then use using evidently AI to calculate the drift,
Mhm.
because you need predictions and whatever actual was there. So that is the model monitoring part. That is more of a responsibility of the data scientist. We can develop that pipeline. The second part is the API monitoring,
You
which
go on the second part. I just have a sorry, Swapnesh.
yeah.
So before you go on to the second part, just a follow-up question on the first part. Um, just to understand, how things work. So let's say, you have one model that a data scientist gave you guys, and you have it deployed, right? And let's say you notice a data or a model drift. Do you also get a backup model from the data scientist, so that if something goes wrong with, let's say, the first model, you guys automatically switch it to let's say the second model? Um, when if it's the model which has an issue, on top of that, if it's a data issue, what is the process? Like, how do you guys resolve that on
So this is something we haven't much uh, poured into, like we haven't done much development in this part. So right now what the process is that when the model drift or data drift is there, the data scientists come back to us that we are going to update the model. So they do it themselves. But yeah, that is something which should be there, that there should be a backup plan as such.
Mhm.
So that would come when things get more evolved in this part of the pipeline. But yeah, right now that is not there, that we have a backup plan for the data or for the model. Whenever they do this analysis, they come to us that we are going to update the model, and whatever like feature store is also there. So basically they would update their features also. But yeah, ideal in ideal world, this is what should be there. That something gets triggered to a fallback.
Mhm. Yeah, because they reminded me because I was working on a project recently of forecasting and deploying it into production, and that's what I thought about. So what if something goes wrong on that end? All of a sudden the model gives, let's say, 30% margin of error, and
Mm.
now it's pretty bad because the stakeholders will be making decisions based on that. Then what do you do, right? I mean, how do
Mm.
you resolve it? Do you tell the stakeholders like, hey, you know what? Right now it's bad. Don't rely on it,
Mm.
or switch it over to different model. Um, and then if you switch it over to different model, also beforehand, you don't know which model is going to perform better,
Yeah.
right? You work on a couple of different models, you pick the top two, and you have the top two that performed better on the past data,
Mm.
and you have one which is in prod, and let's say another one which is in the dev mode, which you switch it over to. So yeah, I think that is something really
Yeah.
important to think about. There's a lot of complexity, I think,
Yeah,
surrounding.
switching in case of a drift is not only related to the model or data, it's more of a business problem,
Mhm.
because if you even want to switch back to your previous model, your data has already drifted,
Yeah.
because that model was trained some 2 months back or 3 months back. The current data is not that, like according to that model.
Mhm.
So that model will also not work. So your fallback would be something like you have some fixed rules that you have written, that if my model starts predicting in this range,
Mhm.
then I should rather switch to the business rules
Mhm.
and then look at whatever is going on for the model.
Mhm. Yeah.
So it's like really complex when you want to go to a fallback.
Mhm. Yeah. Yeah, and so tell us about this architecture that you have, right? So, which is what you've been talking about, like monitoring. You have the feature stores for the features. Why is it important to have feature stores? Like one, that. The second thing is we've been already talking about the importance of having a monitoring in place so that we can monitor the model KPIs, but not just the model, but also the system's KPI to see how our system's performing. On top of that, tell us about um, how do you connect all of this together? Who would take care of which aspects? Yeah.
Okay. Uh, so basically, I'll start with feature store. So first, the first time we learned about feature store, that name is not exactly what it does. Like if you read feature store, you would rather think about some store where you store your model's features, but that's not what it does. Its job is very different from that. You can store your features also, but its main job is that it will store that static data which your model has had used to get trained on. It's not exactly the training data, but that small data sets which you use to do some tuning of the model. Like in our case, I would say the make model variant and ex showroom price, or different type of, you can say, clusters which were getting assigned to different type of customers or different type of cars on their listing. So it's like when you deploy your service, there are multiple CSVs which you load, which contain some sort of static data. And in your runtime, you would rather do some sort of basic lookup so that you are able to, the post request which you get on your web API, you use some key to find that some value which is basically static and gets updated like maybe daily also. In our case, uh, one example which I can give is that multiple cars get listed and delisted, and there is one model running which finds out whether this car or person was blacklisted or not for some random reason, whatever there is. So how do you keep that data? uh, you cannot keep that data where your service is running, because it is getting updated daily. So you would rather need that data at some place where you are able to do a quick query. It's not exactly a database because you're not doing a where clause anything. You just want to do a key value lookup. So you don't use a relational DB. You need something like Redis, which is very fast because you don't want to do like calculation as such. So feature store job is this, that it is able to offload these sort of static data from your API to some DB as such, you can say, which is giving you real-time results. So, and the basic use is that. The other which the other can say advantage it gives is that you don't have to update your service when this sort of data gets updated, because your service, your model is running independently of what these static data are like when they are getting updated. So which also helps in reducing your docker images size, because you are not putting these CSVs or JSON in that. And also it will save your memory, because you're not loading everything in the memory using pandas or anything like that. So there are multiple use cases for feature store, and that's how it helps. And because its functionality is that it keeps two types of stores. One is your offline store, one is your online store. Offline store maintains your history of what all was updated since the you can say the schema was created, and online store gives you the current data. So let's say a make model variant key is there, and the value is X showroom price. So let's say once a year this gets updated. So at some point you would want like every time you would want the current X showroom price. So this online store, its job is to keep that current data in its memory itself. No, you don't, that doesn't care about what the previous values were there. And because the online store is something like Redis, so it's running in memory, so the response time from this API is less than in 10 milliseconds. So it doesn't actually hamper whatever your response time for the entire API is. So these are the basic use cases for feature store. And Feast is that open source library which is able to provide that. Sorry, what the other question was? I forgot.
I didn't know that, right? I always thought, because I never use feature stores in my day-to-day work, but I always thought feature store was something like, where you store features.
Yeah, like
Right?
its name suggests that it's something like that, but it's and use cases is very different.
Yeah, and people on LinkedIn, they will talk about this, and they'll talk about, doing feature engineering and then storing those features onto the feature store. And then when you have offline versus online, you would extract those features, right? So always had in mind that, okay, it's a place where you store the features, right? So
Yeah, so because it has online and offline store, so
yeah.
obviously you can store your features as well, because it's
Mhm.
just a key value lookup, nothing else. But its main job is that whatever static data which you had used to train your model, which you will also need in your production,
Mhm.
it's able to store that part and able to return you that key value lookup as quickly as possible.
So you can use any what do you call non-relational database for that, right? Like, is there anything special that people are open sourcing a lot of different tools in that on that area? Because I see Feast, right? I see a couple of other popular ones, popular features to
So
platforms.
basic requirement for such tools is that you have to maintain two sort of DBs. One is your offline and one is your offline online store. Basic requirement is that, so that there is some link between these two, and for whatever key you have the current data itself, and you can also find out whatever was updated in your offline store. And offline store is something like BigQuery or even Snowflake or anything like they keep on adding more offline and online stores. So basic requirement is that there is some relation between these two stores. But if you don't want something like that, you can just deploy your own Redis in that cluster itself, and it will serve the purpose.
Yeah, I think we are short of time, so I'm not going to ask you a little bit more detail into this. I'll let also Ashit ask you questions. But for that, like, would you be able to list out, let's say a roadmap for someone who wants to be a machine learning engineer? In that
So
roadmap,
let's make it a little bit more specific. Like if someone is a data scientist, then and he wants to switch to MLE, then can you give a roadmap for that?
Okay.
including the
So,
tool, right? Like we'd be interested to see, and you can spell name the tools as well, right? Because we'd be interested to see which tools that you use, today. So yeah.
okay. So the basic step starts from when you start deploying service. You can use Flask, you can use Fast API, whatever works for you, doesn't matter. When you deploy that service, the next thing which actually should come to your mind is how is this going to scale? So you Google things like how to scale my Fast API or my Flask app. They will give multiple results, and some of those results will say Docker. So then you learn about Docker. What is Docker? Docker is something like your computer minimized and running on another computer. Because generally what people say is it was running on my PC, why it's not running on some other PC. So you ship it like your own PC itself. So okay, that comes the second part, that Docker is something which will give me something which will scale my API in that VM itself, or where I am running my Flask. That is Docker Compose, which can scale inside that. Okay, so you have got some idea of how scaling works. At some point, you would want that you would think about what happens when my VM's resources are getting full. How do I scale that VM? I can't get every time keep updating that VM. So what is something which scales VMs and manages that and everything, networking and everything? That comes as Kubernetes, which is basically your which monitors and scales your uh, Docker pods, which we call them, and even the machines which are running on that. So you learn about Kubernetes, how scaling works. So this is basic, which the person at some point would like to know if they want to get into MLE. Kubernetes is a very big topic, so it will take time. There are a lot of moving parts in Kubernetes. I'm still not, I would call myself that I'm an expert in Kubernetes. Many Kubernetes certified professionals are also there, but I'm pretty sure no one knows full extent of Kubernetes. So Kubernetes is something you keep on learning itself. So as a starting point, I would say that get till Docker Compose. You should know how to scale your instance of your API, not the entire VM. And when you work on Docker and Docker Compose, you will understand things like how much resource is my API consuming, and you would learn things like what is you can say code profiling. So there are multiple code profilers, Python code profilers also. So you would learn about those things. It will tell you which line of your code is running slow and which function is running slow. So then you can actually think and Google about why is this running slow? Why is Panda slow? Pandas is supposed to handle a lot of data. Why is it slow? So you will find things like Pandas is not designed to handle one row of data, and NumPy is not designed to do np dot sum of one row of data. Python's inbuilt functions are much faster than that.
So do you use a open source? Because I just Googled, Python profiling, for instance, right? And I see a lot of different like companies who provide like Datadog, for instance, right? Who provide um, like visualization of your Python performance. So would you recommend like the third-party tools like those, or build your own thing from scratch?
So Datadog, that is something which in the starting I won't suggest, obviously, because that is something which requires an entire infrastructure, because that whole setup is to be put for every service now. So don't start getting into that. You can use basic Python profiler. You can do a pip install also, and it will run as a decorator on your Python functions, and it will give entire stepwise profiling of your function, each line. So basically the aim is to uh, get comfy with your Python code, that whatever I'm writing is right. So what even I did in my first 4 years was most of the things which I wrote as a training script, I copy pasted on the inference script, because the steps are same. Instead of loading the CSV, now I'm just getting a JSON which I'm loading on a pandas data frame. So most of the things is that you would want to profile your code and understand why I am writing this line. And that's why I said that software engineering, backend engineering plays a role, because there at least they have to uh, in the least part they have code reviews. As a data scientist, I don't think many companies they do code reviews, because who cares about that inference script?
Let alone code review. I don't think many organizations even use GitHub in a way that it's supposed to be, like as a
Yeah.
team. Right?
Your job as a data scientist is that have you trained the model? Is its accuracy, precision, recall, is it good? That's all. So that's why you need some sort of understanding of how to write code.
Uh,
So, and that comes when you start profiling your code. You have to understand why is this line running slow, and that is more of I'll say that it comes with an interest also. Sometimes you are not interested in it. Not everyone cares about it.
yeah.
But if you have some interest in that part, like how the model works at the base, then you would go into that part.
Uh-huh.
You will go into how this model was written. Why is it running on one core? Why not two cores? Why is XGBoost able to utilize all cores and not linear regression is not able to do it? Logistic regression is not able to. Why? You would not actually write the code for logistic regression, but that gives you a sort of curiosity that I should look at these things also when I'm writing my API. So you have got, like, I think as a fresher, 2-3 years experience, if you can go to Docker Compose and have a basic understanding of Kubernetes, that should be enough to write basic deployment pipelines and showcase whatever you have built on your GitHub. And that just is an entry point to whatever you can build. But yeah, that also depends on whatever company you are joining and how much they are invested in building this infrastructure as such.
Also, tell me about the interview process. Like when you switched to Cars 24 as a MLE2, right? So, what was the interview process? What all, uh, what all did you have in your resume at that point of time, and what all worked for you?
Yeah. So
Actually, on top of that, I'm just gonna add something on top of that, because your journey was slightly different than how you would be now. So if now people, that's a lot because I got Cost 24. It's one of those companies that I strongly recommend a lot of people whenever I see hiring at Cost 24. I actually shared with a bunch of people because I feel like you guys are doing a great job and you guys are pretty strong, not tech tax team. And you guys could really use your brain to go, with remarkable things. So now, on top of that, now if people want to get into Cost 24, how does the interview process look like? And what do you guys really look for in the resume?
yeah, so I also do my hiring for my team. What basic understanding I would like to give anyone who wants to apply for any position is that don't put your resume for all types of roles. You have to tweak your resume corresponding to whatever the role you are applying to. If you are applying to an MLOps position, your resume should have things like I saved this much time, I saved this much cost, uh, I built this pipeline which optimized this. These sort of things should be there in your company or project or whatever you have done. Because as an as a hiring manager, I would like to see what all you did which was going wrong before and you corrected it. uh, Anyone can learn about Kubernetes. I can hire someone and give them 3 weeks. Yes, go and do all those courses and run out. Think about it. But do you have that acumen to identify that this was going wrong and I thought about something and I corrected it, and this in turn saved this many hours of work or this much cost, saved this much cost for the company. So that is something I would recommend everyone to tweak their resumes, not only for MLOps, for any position they are applying for. In terms of hiring process, like what I do is that first basic screening is like obviously the resume part. Second basic screening is that I prefer giving a simple assignment, that do some training, whatever training. I don't care about the precision and accuracy, but when you have you have built the model, uh, write an API which can do predictions and build around that whatever architecture you are planning on that. If let's say I have to build a real-time API, if I have to build a batch API, how is your like entire pipeline going to look like? What are the things that you would be taking care of? If I've seen that in your resume you have written Kubernetes, then I would expect a YAML file, that what is the YAML you are writing, and obviously Docker file and how you write a Docker file. Then you should obviously know which are the steps you take while writing a Docker file, which will reduce the size of the Docker file. And in terms of MLOps, I would expect you to know that how scaling works,
Oh,
why the API would scale, those sort of parameters like CPU usage, memory usage. How do you monitor that? And basically, if I'm hiring for a like 4 or 5 years experience, then I would expect them to have knowledge about monitoring side as well, because from 2-3 years experience, I don't expect everyone to know about Grafana, Prometheus, and all those things. But yeah, after 4-5 years, you should be taking care of these things also. So how do you do the monitoring? What are the challenges? What types of monitoring you should do? API monitoring, model monitoring, data monitoring, all those things. So yeah, I think these are the basic things which I expect. I don't know what other companies ask in the interview, but I don't like to ask DSA at any point, because it doesn't make sense.
Yeah.
You're not going to solve some back-end problem as such. But yeah, there is some sort of basic coding which I ask in my interview. It will be a very basic Python question. It's just to see that are you able to write the code? Because after GPT, it's very easy to do the assignment and write any sort of code. Even I use it in my daily work. So I do basic live coding round also. Basic questions like do this in a list, do that on a tuple, those sort of things, so that I can see that you are writing the code which you have written in your assignment. Because honestly, I've seen assignments which have been submitted by people, and if you so GPT does one more thing, that if you write this code and submit it, and sometimes you ask through a prompt that have you written this, and there was one prompt, mm, I'm not exactly remembering the prompt. It was something like is this function written by you, or how would you
And
write this function? So
just
it returned the exact same code which the candidate had written in the assignment, exact same with the exact same variables. So after GPT, it's very difficult to do a judgment on the assignment.
yeah, I agree.
So basically, one basic Python coding round is needed right now. But yeah, not DSA. I don't expect them.
Do companies usually ask DSA for
Yeah,
employee?
I
They do.
know that they do ask. Basic DSA round is, I think, in most of the companies, first round.
Hmm.
Like I have a different relationship with, let's say, DSA, right? I know like big companies, because I interviewed at big companies like Facebook and all, they ask DSA, depending on if you're going for ML engineers role, yes, because ML engineers is very close to software engineers. So for those roles, they ask DSAs. Data scientists, it's more oriented towards like the product understanding. So, do you have like do you understand the KPIs that come up with KPIs, right? So you have a product, you're designing something, come up with the KPIs you would use,
Hmm.
right? To understand how
I think mostly companies, the big tech, they have a coding round and DSA round because they receive 10,000 applications.
yeah,
It's their way of doing some sort of cutoff.
yeah,
You should be above this level at least, because we have people at this level.
yeah.
So
But
it works for big tech. I'm
yeah,
not, I don't have any problem with that. But yeah, uh, doesn't make sense for smaller companies.
true. And a lot of people don't even use it, right? Like I said, like big techs. I went for interview at Facebook for a machine learning engineer. I knew that they would ask DSA right away. I was like, I can't do this. You can, reject me, right?
Yeah.
Because I'm confident with DSA stuff, right? Um,
Yeah, because that is something I would have, because DSA is one thing which, if you leave the practice, you cannot do that question.
yeah,
If you haven't done that sort of coding in 3 months at least, you won't be able to solve it. Your
yeah,
brain doesn't run in that direction.
true. And you don't use it, right, on day-to-day
Yeah,
basis. I was
obviously.
like, interview me for data scientist, I'd be happy to do the interview, but for this, I won't. Because, yeah, you learn it, but then you forget because you don't utilize it. It's like object-oriented programming. Yeah,
Yeah.
you learn it. If you don't utilize it, you're going to forget. And a lot of people even, get interview for that, like object-oriented programming. And I don't see the point. Like, yeah, even as a data scientist, I have rarely used object-oriented programming. It's only if I'm building a Python package.
Yeah.
Then yes, I have used it for open source works, but other than that, not much, right?
Yeah.
So I do feel like, it's overrated, like DSA and object-oriented programming when it comes to even just hiring data scientists.
Yeah, for because it's for software engineering, most of the things they are writing, they are reusable among very different APIs. They write classes which get utilized by many other teams. For data science things, it's like very rare that whatever your code you are writing, it's specific that to that model and that data. It will be very rare. Like you might write a wrapper for some sort of data processing which gets utilized by everyone. That in that part it makes sense,
Yeah.
but that would be very a rare case. These are very rare cases. This will be more frequent in big tech because they are running a lot of these models and services, so they obviously need reusable code. But in smaller companies, it's very rare.
Yeah. And I like your idea of, asking take-home assignments, but building a pipeline, right? Because like you said, ChatGPT, people utilize that.
Yeah.
But now, let's say 10,000 people apply for the role. Those 10,000 people, they have to utilize ChatGPT to build a pipeline. But building the pipeline, there's always a lot of edge cases that people have to think about. Like you said, how you write the different scripts, you think
Mm.
about the metrics to monitor. So there's so many different ways to judge a candidate versus giving them, like in the data world, giving them a data and asking the person to do just the analysis. I mean, in that
Yeah,
case,
like
it's easier.
the
Yeah.
assignment which people submit, at some point you are able to judge that whether that person has written this or not.
Yeah.
I did not ask for this much information. Like this code is supposed to be max 10 to 15 lines. Why have you written all these extra steps? I did not ask for it. And it's good that you have written it. I'm not criticizing it. But when I ask them about those extra steps, they are not able to answer. So
Mm.
it's somewhat it's correlated to whatever they write on their resume itself. Reading their resume and seeing the assignment, it gives you some sort of feeling that something is wrong in this assignment.
Like one thing so one time I was interviewing this candidate, and it was a live coding, right? So I asked him just writing a function in Python. Really simple. You can write a function in Python, but then from that end, you can see the best practices that they were following, even just writing a simple function like ipens and try excepts and all of those things, right? And the explanation of it.
Yeah.
Candidate wasn't able to explain it. So I'm like, you have an experience of 2 to 3 years. You know how to write functions. You call yourself an expert in Python, but there's so many different things that you're missing out because again, which I understandable because you don't come from software background.
Yeah.
But you spend years in the industry, and the industry is not teaching that. Right?
Mm.
This is again goes back to not having a solid team. Right? That help doesn't help you grow. Right?
Yeah.
So yeah,
People fail in basic steps like list comprehension.
yeah,
It's very basic thing which you learn in the first year of your data science journey. Somewhere at some point you would have used list comprehension, or not if you have seen it somewhere, because obviously you're not going to write the entire code yourself. You are going to Google stuff. You will see list comprehension. That is the basic thing. Like you should understand that part. What is list comprehension? So even people are not able to like write the list comprehension. Even 3 years, 4 years experience people have seen.
Do you do you get late night calls that this thing is broken? Can you fix it right now?
Very rarely. So till now, there hasn't been some issue that something extreme has broken in our pipeline or a service. So we haven't got that call sort of as yet, but because like I said, we are working on data platform right now. So it can happen at some point. Because you are building pipelines, you are running a platform, that is something you should be prepared for, because things break. But you should have proper monitoring in place, that you are getting notified whatever is happening before business people or tech comes to you. You are able to know that this is broken and I can go and fix this. It should not come from the user of your API.
It's a mess, right? When things break, because
Yeah.
people are like on top of you. Everyone's like, "Oh, fix that," right? Like our data changed like a couple of weeks ago. The data engineers, they did something and the data changed. So all the pipelines that we had, the dashboards that the end users were using, all the numbers were incorrect. Like the turnover, the average basket values, and all of those things, right? All the metrics are incorrect. So past 2 weeks, it was working hard on all the queries that we had, 20, 30 different queries, fixing those, figuring out which query does what, because you didn't write it yourself. It's mix of bunch of people writing different queries. Yeah. So
Yeah.
yeah, no, I've been in that situation. It's just a mess. It's a nightmare. Yeah.
So that's the basic thing. Like you should so that comes when you are writing your code also. You are able
Mm.
to identify uh, where your code can break. You can put some sort of logging, and you can put alerts on those sort of loggings that this is not the right input which I was expecting. So
Unit
you can
test.
get different type of alerts, that you know that this alert is not my wrongdoing. This is coming from whatever the person is calling my API. So I can tell them, and when my API is doing something wrong, then at least I know and I can correct that.
What is the largest Docker image you have ever deployed?
Triton image, basically the
How big
Triton,
is
or I would say a Whisper model which we did.
how big is it?
I think it's 25 GB something, because it has the entire Triton base images itself is very huge, and on top of that, you have to deploy transformer also. Like you have to install transformer in its Docker itself. So we use Triton's base image, then we install transformers and PyTorch, upgrade the PyTorch version. So it goes till around 22 some odd GB, I think.
Hmm. Also, tell me, do you think ML engineering can be automated?
Uh, ML engineering, like not all the things, but yeah, formulating that pipeline, that is something still you can't automate, because
Hmm.
that is something which you get from experience. That let's say you have a problem of streaming data or real time. So these are two different things. Streaming data pipeline and time data pipeline, these are different things. They sound similar but very different. So you know
What is
that.
the
So basic difference is that real time means there can be some lag, 1 second, 2 second, 3 seconds. Streaming is you don't expect any lag. Every box that is there in your pipeline gets the data at like in milliseconds difference. So when you are working on streaming, when you are working on real time, what are the tools you want to use in your pipeline? That is something which comes with experience. That do I need Kafka? Why should I need Kafka? And if I need Kafka, then how much resource should I give to Kafka so that it's able to maintain that millisecond of time difference? So that is something which is needed with experience. But yeah, after you decide on the pipeline, then building all the resources, that is something which can be automated, like basic Terraform scripts you can write. So that for, let's say, an XGBoost model, most of the building blocks would be same. There would be a model repository, there would be a data repository, inference store, feature store, these sort of things. And most of the code in that will be same. Basically, they would do a key value lookup or store something in the response inference store. That is something which you can fully automate. That I just run this Terraform script and everything gets mapped. But yeah, that formulation of that pipeline, that is something person is still needed for. That why would I use this?
Do you think with the advent of LLMs, like do you think MLE is like more and more in demand after LLMs?
Um, I think so. Like,
Or is it the same, like no difference?
I think it's like more demanding right now because how LLMs run and how they are trained, it's entirely different
Hmm.
than deep learning models itself. So for deep learning models, you can just throw in your resources, they will run fine. But if you start doing for LLMs, your cost will skyrocket. Everything runs at scale. There is no problem in that. But
Yeah.
you cannot throw resources at fine tuning an LLM
Hmm.
because it has no limit. So you will rather need some person who has some basic understanding of why this model would need this much resource and can I break it. And the most important thing in this part is that person willing to learn all those things, because that is a very different field. You have to get into how that LLM was written, in which language it was written. You cannot, everything cannot run on Python. So these models basically need C++ sort of things. You don't want to get into C++, but at least you will read about blogs and resources which people have written who have built this LLM. So you get a basic understanding that this is the basic resource I would need for whatever I want to do. So you won't expect that one data scientist to know everything, all that also.
So do you think like for like roles like yours where you deploy things, so do you think you would have to have a different mindset or a different kind of architecture when it comes to deploying LLMs now versus the traditional thing that we've been deploying?
Yeah, so the resources definitely need some upgradation also. So deep learning models, uh, there are very few models which need other than T4 GPU. Most of the things can be done on T4. So, but you cannot train a model, LLM model on T4. It will take like weeks even if you want to fine tune it. So you go into P4, L4, A100s. In A100, then you come across things like multi GPU instances. So you can split your A100 into 7 parts and keep running Triton on those things. So that is a basic level of interest and curiosity that you should have, that I have to get my hands dirty on hardware side as well. I would want to understand how, like, why this GPU is there for this particular piece of work, because generally you don't get into GPUs. Like, why would I want to know about how GPUs work or why this GPU is for this particular model? So basic level of curiosity is to be there when you are working on LLM side, that hardware is something I should be aware of, what problems can arise there itself.
Okay, I
Got it.
think We are out of time, but yeah, Ashit, do you have any last questions?
No questions.
Any last thoughts or comments you want to leave for people out there who want to get in the field, or who are like freshers, or even people want to upgrade themselves to MLD positions, or let's say get to the seniority level?
So what I felt what I am still doing and what I want to do for the rest of my career as such is that you should keep on learning. Cannot limit yourself to, when you're working in data science, you cannot limit yourself to just training the model. That will not work after let's say 5-6 years, when you want to be in a position of principal data scientist, because training is going to be automated in like few years. It's pretty much automated right now. If you are able to clean your data perfectly, you do not need a data scientist to train your model. You can just write your pipelines in AWS itself. Vertex AI is there in Google. If you are able to clean your data, your model can be generated. That is pretty much automated right now. So I don't know what will happen in the next 4-5 years in that space itself. Maybe someone will develop things like it's able to understand data and it is able to clean that data itself. So in this part, you should be aware of how my model is going to perform in the real world, and what are the things I should be able to like take care of when something bad happens in that deployment which I have done. So uh, in terms of learning, there has to be constant learning in this field, not just data science. Even for people working in ML and MLOps, MLOps is progressing very fast. These, like I've seen in the last 2 years since I have just started doing MLOps, I've seen number of companies coming up with MLOps platforms, and they are developing a lot of things, and lot of optimizations are going on in every part of deployment, monitoring, and everything. And with LLMs, it has just skyrocketed everything. So staying updated is the most important thing. That you might be doing something which you think is working fine, but it can be optimized. There has to be something which is more like better. Like we use KServe in our deployments, but I know there are multiple tools which have come right now which are doing better than that, and which require even less involvement from our side when we want to serve models at scale. So that is the basic thing which I have learned in the last 2 years, that you don't know anything. You can just assume that you don't know anything. You just know what you have learned till now. Once you start Googling stuff, you will find that people have done tremendous work in whatever you have learned itself. And it's not easy to keep up, obviously. There are a lot of things, but you should invest some time in that, apart from doing whatever work you are doing. Not, I'm not saying do your weekends, don't spoil your weekends, but at least give some hours in the week to this part, that learn about this model is there, what is the back part of it, what is going on in the front part of it when you take something into production. So yeah,
Thanks for sharing that message. And I hope people really focus on what you said, and do things, thinking, think about long-term vision, and do things in a right way,
yeah.
as of now. And I agree, everything's getting pretty populated, and it's hard to figure out which direction to go. But
Yeah, there is
yeah,
no one tool to do something. If you just Google that, I want to deploy my model as such, what are the tools available? You'll find a list of 15 things, 15
yeah,
different tools. then how do you do a benchmark? No one is going to do that benchmarking for you.
Yeah, exactly. And yeah, I think a lot of that comes down to, just understand the basics yourself.
Yeah.
Those tools, they are built on some foundations. I mean, each tool might differ by, just one feature. Like one platform might be offering something in addition to other platforms, right? But having that basic foundations, understanding what is really underneath that platform,
Yeah.
what is, right? And if your company, all of these tools, yeah, at the end of the day, the companies have to pay for it. They don't come for free, right?
Yeah.
So if the company is not willing to pay for it, you should be able to replicate those. So having that strong foundation will help you to, to build that to for your company in-house, right? So yeah. One final question I have before I let you go is about the Medium articles. I see that you guys, as a team, you guys, write a bunch of articles, share insights with each other. How do you guys go about, writing articles, and how do you even get started with that?
Uh, so basically, the articles we write, uh, so that is something we have to take time out for. So since the last article, we have done a lot of things, but no one has got the time to actually sit down and write these articles. Uh,
Is it the company's policy, or is it just you guys are really interested
Not
in?
company's policy, as a team. So the medium account is cast 24 data science. Not exactly remembering
Mhm.
the name. So it was an initiative of the whole data science team. So we also are a part of data science team. So it was an initiative that we tell the world as such what are the things we are working on. So as an MLN team, we put more on emphasis on what optimizations we are doing and what tools we are using and how we are researching on them. Data science team, they put whatever they have, the logic they have used to solve some problem, what model they have used or what optimization they have done in solving this particular problem. So they write articles on that. BI folks, I think, I don't know that they have written something, but yeah, they also are planning.
Mhm.
So that it's basically a sort of a team initiative that whenever you get time, so you write about things that you have worked on. And because my team, like, we are a very lean team, so we are around three of us, and if you count my manager, that is one third, because he has other things also to do. So we are a very lean team. So basically everyone is doing, like, everyone is aware of what other person is doing, and we keep on helping each other in every part. So that's why in every article we write the name of everyone, so that
Yeah.
because at some point that other person would have told something in respect to whatever the work was done.
Yeah. No, that's amazing. That's great. Yeah. And it's hard to find people like who can invest time and who can come together to teach each other and write articles, like blogs about it. So no, great work.
Yeah.
Well, thank you, Swapnesh, for your time. And I know it lasted longer than we expected. The
No,
conversation interesting.
this is
Thanks again.
something I like to talk about whenever someone else, like in offline session, someone wants to ask me about this field and everything. So
Mhm.
this is the first time I'm doing online. So but it's not an issue for me to talk about how I got here and what are the challenges and everything. Just everything what I told in this session.
Yeah, thanks you. Thank you again. Yeah, we'll share it. We'll upload it and then we'll share it with you and on LinkedIn and other platforms so that
Yeah.
people can learn something from it. Yeah, thanks again for your valuable time and stay in touch.
Sure, sure.
That's
It's a pleasure.
Thanks.
yeah.
Okay. Have a
Good night.
Okay. Good night. Yeah. Bye.